Okay, let's talk about section 7.3. Computing the values of trigonometric functions of acute angles. Computing the values of trigonometric functions of acute angles. Okay, so basically we will set up the most important values. So first, let's talk about pi over 4. Pi over 4. Pi over 4 is 45 degrees. Of course, pi over 4 is acute angle. If we place pi over 4 in the right triangle, this is an isosceles right triangle. So here's a 45 degree, here's also 45 degrees. And those two legs are equal. So you have A, and hypotenuse is C. Okay? So this is an isosceles right triangle. Isosceles right triangle. Isosceles right triangle. Then by the Pythagorean theorem, c squared is equal to a squared plus a squared. It's a 2a squared. So c is square root of 2 times a. Okay, so this is a relation. A root 2 times a. Now let's talk about 45. Let's use this one as a theta. So sine 45 is opposite over hypotenuse. It's a over c. Opposite over hypotenuse. So it's a over square root of 2 over 2. A cancel. We have 1 over square root of 2. 1 over square root of 2. We multiply top and bottom by square root of 2. So square root of 2 times square root of 2 is 2. So it's square root of 2 over 2. So sine 45 is square root of 2 over 2. Cosine 45 is the same thing, adjacent over hypotenuse, but adjacent is also a. So it's also square root of 2 over 2. You have sine, you have cosine, then tangent 45 degree is sine 45 degree over cosine 45 degree. Root 2 over 2 over root 2 over 2 is 1. Right? And then you have sine, cosine, tangent. Other three will be cosecant 45. Cosecant 45, we're going to use this formula. Sine 45 is 1 over square root of 2. Then cosecant is reciprocal, it's the square root of 2. Secant 45. Secant 45 is 1 over cosine. It's the same thing, square root of 2. Cotangent 45. Reciprocal of 1 is 1. So that's all 6 values. Root 2 over 2, root 2 over 2, 1, root 2, root 2, and 1. And to get this, all these 6 values, we use isosceles right triangle. That's from the geometry directly. Right? So you can, for example, compute secant pi over 4 times cotangent pi over 4. Pi over 4 is 45 degrees. Secant pi over 4 is square root of 2. Cotangent pi over 4 is 1. The product is root 2. Right? So just use whatever trig functions and try to compute the values. First pi over 2, pi over 4. So sine pi over 4 times tangent pi over 4. Sine pi over 4 is a root 2 over 2. Tangent pi over 4 is 1. Product is just root 2 over 2. Okay, So this is a first concrete computation for the trigonometric functions, trigonometric values. Now let's look at the other one. The second is talk about pi over, let's talk about what? Pi over 6 and pi over 3 together. They are complementary. You know one, you know the other one. You know the trigonometric values for one angle, you will know the trigonometric values for the other angle. So these are complementary. Complementary pair. Pi over 6, how do I draw it? We draw an equilateral equilateral triangle, right? So what's what's that word? I don't see the word. Let me find the word. Yeah. For an equilateral triangle, all three angles are pi over 6, pi over 3, my bad. Pi over 3, pi over 3, and pi over 3. 60 degrees. 60, 60, 60. Okay, and then three sides are C, C, and C. Three sides. And we cut it, we use height to cut it. This is a pi over 2. Then the top angle will be pi over 6. So the half of the equilateral triangle is a right triangle with one angle pi over 3, the other angle pi over 6. And then this side is A. This A is equal to half of C. Okay, this side A is equal to half of the C because this right triangle, right triangle, they are identical. So this is A, this is A. The total 2A is C. So A is a half of C. Okay, then what is a height? Height will be the B, right? The opposite for the pi over 3. So this is right triangle, we have the Pythagorean theorem. A is half of C, so it's 1 over 4 C squared plus H squared. So we move 1 over 4 C squared to the left side, it's 3 over 4 C squared is equal to H squared. So H is square root of 3 over 4 C squared. You move C forward, you move 2 forward, you will get the square root of 3 over 2 times C is equal to H by the Pythagorean theorem. This is the opposite of pi over 3. Okay, so sine pi over 3 is the opposite over hypotenuse is H over C. H is root 3 over 2 times C over C. C cancelled. So sine pi over 3 is square root of 3 over 2. This quantity, this number comes from the Pythagorean theorem plus this equilateral triangle. Okay, and cosine pi over 3. Cosine pi over 3 is adjacent over hypotenuse. Adjacent, where's adjacent? Adjacent is 1/2 of C over C. So it is equal to 1/2. Okay, so let's recall what we do. We start from an equilateral right triangle. We cut it into half. Okay, we start from equilateral right triangle. We cut it into half. and so the base is just half of the side. So A is a 1/2 of C. Then we're looking for H by the Pythagorean theorem. H is a square root of 3 over 2 times C. C is a hypotenuse. Okay, so when you talk about pi over 3, H is opposite. Base A is adjacent. C is a hypotenuse. You follow the definition, you get the corresponding value. And you have sine, cosine. What is the tangent? It's a sine over cosine. It's just root 3. Cancel 1/2 with 1/2. And then you flip all three quantities, you will get the other three trigonometric values. Okay, so you can get cosecant pi over 3 as 2 over square root of 3. It can be written as 2 times square root of 3 over 3. And the secant of pi over 3 is number 2. And cotangent pi over 3 is 1 over square root of 3 is square root of 3 over 3. Okay, so 1 over square root of n is always square root of n over n. Okay, so we have the 6 values, 1, 2, 3, 4, 5, 6. We'll start from 2. We get the rest of the 4. And when you have sine, cosine for pi over 3, you use that co-function and the complementary pairs, you will get sine, cosine for pi over 6. So there is a table on page 531. There's a table. The table gave us the sine, cosine for the pi over 3, pi over 6, and the pi over 4. Let me copy it here, and you are supposed to memorize them. Okay, so we have pi over 6. Pi over 6 is 30 degrees. And pi over 4. Pi over 4 is 45 degrees. And pi over 3. Pi over 3 is 60 degrees. And then the sine value, pi over 3. Sine pi over 3 is cosine. Sine pi over 6 is cosine pi over 3. So it's a 1/2. This one is a square root of 2 over 2. This one is a square root of 3 over 2. You see, sine pi over 3 is square root of 3 over 2. Sine pi over 6 is cosine pi over 3. That's what I have. Cosine is square root of 3 over 2. Square root of 2 over 2. And a 1/2. And tangent is square root of 3 over 3. And 1 square root of 3. Cotangent is square root of 3, 1 square root of 3 over 3. And the secant is 1 over, okay, so it's 2 times square root of 3 over 3, and square root of 2, and the reciprocal of cosine is 2. And the cosecant is 2 square root of 2, and the reciprocal is 2 times square root of 3 over 3. Okay, so this table is very, very important. It's very, very important. For 30 degree, 45 degree, and 60 degrees, you're supposed to know all the trig values. But as we always emphasize, the last 3 values are just the reciprocal of the first 3 values. So you memorize the first 3 values and flip them, you will get the last 3 values. So you don't have to actually spend time to memorize this half. Just memorize the first half, and then you will get the by reciprocal numbers, you get the last 3. Okay, so that's a memory job. This value table is very, very important. is very important. So for example, let's try for example, they ask you to find what is a sine 45 degrees times a cosine 30 degrees. Okay, 45 degrees sine is root 2 over 2, cosine 30 degrees is root 3 over 2, so it's root 6 over 4. And if they ask you to find the tangent pi over 4 minus sine pi over 3, tangent pi over 4 is 1, sine pi over 3 is root 3 over 2, so it's just 2 minus root 3 over 2 over 2. Okay, see, if they ask you to find the tangent pi over 6 squared plus sine pi over 4 squared, this is 4. Tangent pi over 6 is square root of 3 over 3, and then squared. Sine pi over 4 is square root of 2 over 2, and squared. This is 1 over 3, and this 1/2 is 5 over 6. Okay, so just memorize the table and get the right answer. If you couldn't memorize the table, at least you memorize the sine cosine, because tangent is just a ratio. You memorize sine cosine, you do the sine over cosine, you can get the tangent. So it's a very boring job, but it's a very important job. Now let's try to study some application or the word problems in this trigonometric steps. Example: a rain gutter is to be constructed of aluminum sheets 12 inches wide. Okay, after marking off a length of 4 inches from each edge, the side went up at an angle theta. Okay. Question 1. Express the area A of the opening as a function of theta. Okay, so what is this problem? The problem is the following. So you have a 12 inches wide aluminum sheet, and you mark it 4 inches length. So this is the total is 12. This is 4 inches. This is 4 inches. So the middle is also 4 inches. And once you get this, you fix the middle part and bend the left side and right side up. Okay, And where is the angle? The angle is here. This is angle theta. So you bend it up to get a ring gutter. Now we are talking about the area. What is area? This is area. Area of the opening. This part. Trapezoid. Okay, so for this, what's this word? Trapezoid. T-R-A-P. Yeah, trapezoid. What is a trapezoid? Trapezoid means you have two sides parallel, other two sides not known. This is a trapezoid. The area of the trapezoid is the sum of a top base plus a bottom base times a height and then times 1/2. This is area. Okay. For this one, this is a so-called isosceles trapezoid. It means it's very symmetric and two sides as two non-parallel sides are equal. Okay, and let's check what is the area. The area, we need the base, bottom base and top base. We need the height. Right? We need both. This is also theta. The height is easier. If we connect these two, if we draw this height here, the height is the opposite side of theta. So h over 4. 4 becomes hypotenuse. If you bend it up, 4 becomes hypotenuse. H is the height. Height over hypotenuse is sine of theta. So h is a function of theta. So from here you get h is equal to 4 times sine of theta. So that's a height. And the top base, what is top base? Remember, this is a symmetric region, a symmetric shape. I compute this part. This is adjacent of, let's put A here. This is adjacent of angle theta. So the adjacent over hypotenuse is cosine theta. So A is hypotenuse times cosine theta. And then you lift this A to the top part. This is A. And symmetrically, this is A. You have two parts, 2A. In the middle part is 4. You lift this base 4 up. So by the formula, by the area formula of the trapezoid, the area is 1/2 bottom plus top. Top is 4 plus 2A. And times height. 1/2 bottom base plus top base times height. So height is 4 cosine theta. Height is 4 sine theta. A is 4 cosine theta. So it's 1/2. This is 8 plus 2 times 4, 8 cosine theta and times 4 sine theta. And if you simplify it, it is A is equal to 1/2 times 4 is 2. So it's a 2 sine theta, 8 plus 8 cosine theta. And you can leave it like this. Okay, so this is the answer of the first part. Express the area of the opening. Express the area of the opening as a function of theta. This is a function of theta in terms of sine and cosine. Okay. Second one, find the area A of the opening for theta being 30 degrees, 45 degrees, and 60 degrees. theta is 30 degrees. You have 2 times sine 30 degrees, 8 plus 8 times cosine 30 degrees. 30 degrees, sine is 1/2. Cosine is square root of 3 over 2. So 2 times 1/2 is 1. So it's 8 plus 4 times square root of 3. 8 cancelled with 2, you get 4. If the angle is 45 degree, so you get sine 45 degrees here. 8 plus 8 times cosine 45 degrees. 45, sine 45 is root 2 over 2. 8 plus 8 times cosine 45 is root 2 over 2 also. So you cancel 2 here, you get the square root of 2. 8 plus 2 cancelled with this one, with this 2 in from the denominator, you get 4 square root of 2. So it's 8 square root of 2 plus 8. Square root of 2 square root of 2, the product is 2 times 4 is 8. Okay. And A60 area for angle equal to 60. So 2 sine 60. 8 plus cosine 60. 60 sine 60 is root 3 over 2. Cosine 60 is 1/2. So it is cancel 2 is 2. Square root of 3. 8 plus 4 is 12. It's 12 square root of 3. Okay, so that's the value. In the exam, once again, in the exam, leave answer like this. Don't estimate. Don't write them as decimal approximation. That's useless in our class. Okay. Next example. If a person stands here, something is above, and then when the person observe this stuff, observe this high object, then he looks at it. There's a line of sight, and they have the horizontal sight. Horizontal line. Then this form an angle. This angle is called the angle of elevation. Okay, so if you observe something high, you get angle of elevation. If you stand very high, there is an object very low. You look at this angle, you look at this object, this is line of sight. Then the angle formed by this line of sight and the horizontal line is called the angle of depression. Angle of depression. Elevation, you look at the higher object. High object. Angle of depression, you look at the low object. Okay. Okay, so let's use those stuff to compute something. It's a word problem. Let's try to first write down the problem. Example. Meteorologist find the height of a cloud. We want to know how high the cloud is using an instrument called a ceilometer. What is a ceilometer? Okay, let's avoid the words. Let's just talk about some abstraction. So there's a cloud. There is a light projector. It's right below the cloud. It projects some light to it. Okay, it's a light projector. And then there is certain distance from the light projector. There's some equipment. It's called a light detector. This light detector. Light detector can catch this light spot on the cloud. And then we measure the angle formed by this this is light beam. Formed by this angle of elevation. Okay, so we want to get this. And check here, the base is B, like the distance between the light detector and the light projector. This base is B. This distance is on the ground. We can measure it. We can measure this. So by this instrument, we can compute the height of the cloud. How? Let's call this height H. The base is B. And we can also use some instrument to measure the angle of elevation. So assume the angle of elevation. Theta is 75 degrees. And assume the base B is 300 feet. These two quantities can be easily measured, not computed, measured. Then what is the height? Height opposite over adjacent is tangent theta. Opposite over adjacent is tangent theta. And we're looking for H, so H is B times tangent of theta. B is a base. Theta is 75 degrees. So if you compute this quantity, it will give you the height. In the exam, you just leave the answer like this, because we don't know the value of tangent 75 degrees so far. So you just leave this symbol like this. Don't estimate, don't approximate, don't use calculate. Okay? This is a theoretical result. And in real life, when you have the calculate, you can use calculate to compute. It's about 1,120 feet. 1,120 feet. It's very high. Okay? So this is an angle of elevation. Angle of elevation. And another one. Let's try to compute the height of some statue. What is the height of statue? You have a tall building. On the ground. on this on the roof of the building, there's some stature. We don't want to climb up to the roof and measure the height of stature by hand. We want to really compute it. How do we do that? We stand away from this building, and we can measure the distance between ourselves and the building. This is like the base. And then we measure the angle of elevation twice. How do we do that? We measure the angle of elevation once when we look at the feet, and second time when we look at the head of the statue. Okay, remember we have two angle of elevations, theta 1 and theta 2. Okay, and then how do we do that? This is height h2. This height h1. Then h1 over the base is the same. Opposite over adjacent is tangent theta 1. And h2 over the same base is tangent theta 2. We can use instrument to measure those two angles, and we know the distance from ourselves to the building, the B. So we get h1 is b times tangent theta 1. h2 is b times tangent theta 2. Then h2 minus h1 will be the height of the statue. Right? So h2 minus h1 is b tangent 2 theta 2 minus b tangent theta 1. So then this is a statue, the height of the statue. And this is an example on page 535, how they work out the problem. And once you reach this formula, you just plug in the data. Theta 1 is like 55.1 degrees, theta 2 is 56.5 degrees, because you need the calculator, so we just skip the computation. You need to understand the process. How do we do that? Alright, so this is the section 7.3. In the section 7.3, we have the important table. This table, it is very, very, very important. How do you memorize it? Let's memorize this way. You see, I usually memorize this way: 30 degrees, 45 degrees, 60 degrees. 30, 1/2. They always have denominator 2. 30 is 1. 45 root 2. 46 root 3. 1 is actually root 1. Root 1 is 1. So you see here it's increasing 1, 2, 3. The denominator is always 2. Numerator is always square root. Square root of 1, square root of 2, square root of 3. So sine is. What is the cosine? You switch them. 3 to 1. 3 to 1. Root 3, root 2, root 1, and 2 to 2. Okay? So this is a way to memorize the trig values for sine, for the 30, 45, and 60 degrees. This way. In the table, in the textbook, the table is drawn in this pattern, but I prefer the horizontal one so that you can really see that it's 1, 2, 3, 3 to 1. One is increasing, the other one is decreasing. Okay, be careful. This table is extremely important. You must memorize it. You must memorize it. Okay. Okay, so we will continue the discussion in the next video. Do your exercise. Ask me question send me email if you have questions. Okay, thank you.